Okay, last page of lesson 3. We've got two problems. One where one of the reactants was never held constant, and one where we get a slightly unique order. So, first one starts off simple enough. In trials 1 and 2, the NH4 plus was doubled, the NO2 minus was constant, and the rate went from 1.35 to 2.7, so that's doubled, which means it's first order with respect to ammonium. Okay. NO2 minus, we have a bit of a problem. The NO2 minus doubles in the last two trials, but so does ammonium. Okay. That's unique. That means either the experiment was poorly designed or they were just dealing with the data they had. That can happen. Sometimes you only have a certain amount of data that you can work with. That's okay, because we already worked out the order with respect to ammonium. We can predict what it will do. So when we look at the rate, it goes from 2.7 times 10 to the minus 7 up to 1.08 times 10 to the minus 6. If I put that in my calculator, I see that it's 4 times bigger. So it has quadrupled. We know that doubling the ammonium will double the rate. So of that quadrupling, half of it is caused by the ammonium, which means the other half is caused by the NO2 minus. And that leads it to be first order. When it doubled the rate. Okay? So the basic idea there is you take the one that you know, figure out what it would do to the rate, subtract that effect, and whatever effect is left was caused by your second reactant. So they're both first order. We end up with a nice rate law. K times NH4 plus times NO2 minus. We can solve for K. I'm just going to use the first trial. So they're both 0.1, which is nice. And we're left with 1.35 times 10 to the minus 5. When I work out the units of K, I get molar to the minus 1, seconds to the minus 1. As we've been getting for all of our reactions that are second order. All right. Last one, an order that is a bit unique or unexpected. So again, this problem starts out fairly straightforwardly. For iodide, 13 to 26 is doubled. The other two are constant. And the rate, that's doubled, isn't it? If I make these all 10 to the minus 3, this one would become 19, which is double 9.4. Okay. If you're not confident with that math, just put it in your calculator. 1.9 times 10 to the minus 2 divided by 9.4 times 10 to the minus 3, and you'll get 2. And you'll know it's double. All right, so that's first order with respect to iodide. Okay, let's keep going. Looks like trials 1 and 3 hold iodide and hydroxide constant, so let's use that. When iodide is constant and hydroxide is constant, OCl minus has halved, divided by 2. The rate also halved, 9.4 down to 4.7. Okay, we have another first order. First order with respect to OCl minus. Okay, so far so good. Hydroxide. It doubles in the fourth trial. So which trial had these constant? The first one. Okay, so doubled when these two were constant. And what happened to the rate? Oh dear. 9.4 down to 4.7. It halved. This is unique. Half is 2 to what power? Half is 2 to a negative power. It's the inverse. Our order of reaction is actually -1 with respect to hydroxide. What that means is that hydroxide is actually an inhibitor of this reaction. You'll learn about that if you take AP biology. Inhibitors are things that slow reactions down. If we add more hydroxide, the reaction will get slower and slower. Chances are it's reacting with something. It's reacting with one of the reactants, and decreasing it, or it's causing a complex that's making collisions less likely. Something is going on with OH minus that is stopping this reaction. So your rate law is K, I minus, OCl minus, and then OH to the -1 power. And after that, it's all the same as what we've been doing. You could plug in data if you wanted to search for K. Divide by your concentrations. It's OH to the -1, so I could actually just put OH on top rather than divide. And I get 60.2 when I put that in my calculator. That's actually too many sig figs, isn't it? 60 dot. Sorry. And units. Ooh, interesting one for units, eh? So K is rate times another molarity divided by molarity squared. So all the molarities cancel, seconds to the -1. And that's that.